This is Mr.
Yeah, it's Mr.
Thank you.
Lucky. LIU. Thank you.
Okay, good afternoon. Before we begin, I was looking for someone. Mr. Liu Chen Hui, are you here? Mr. Liu Chen Hui? No? Okay, so let me begin. So thank you in the first place for the mock-up exam that you attended. I know it's a bit of chaos, but that's the purpose of the exam. We are trying to find out what are the technical problems. But it turned out that there are many technical problems. Some things shocking and something surprising, everything we have. But anyway, thank you very much. We are trying to work on it. And hopefully 2 weeks from now, it is a PE exam. We'll have a better system to do that. Huh? Okay, I dropped off last week on this debugging part. I want to show this particular debugging. Okay, so this is from last week. So we talked a little bit about debugging and also introduced a system called Python Tutor. And I'm going to use that quite extensively for the rest of the lecture. So I want to embark on that. So let's look at this program. This programs, what it does is that it is a game, right? You want to add two numbers. So system randomly generates two numbers from 1 to 10. And then it adds up the number and then asks user to give an answer, right? He prints the two numbers to user and asks the user to do to provide the answer, right? If the answer is the same as the number sum up, then it's correct. Otherwise, you say no. I tell what's the actual answer. So when I run this program, it starts by giving a wrong. User starts by giving a wrong answer, right? 4 plus 9, it says 10. So the system says, no, the answer is 13. So everything looks correct here in this program. Make sense? So it takes in two numbers, random numbers. It prints out the statement, what is 4 plus 9, the two random number. And then wait for users input. And then you add up and see whether the input is the same as the actual answer. Right? If it's correct, then you say correct. If wrong, then you tell the user what is the answer. So next I do it, what is 6 plus 5? User enter 11. He said, nope, the answer is 11. The next one, 5 plus 9. He said, nope, the answer is 14. Okay? I think you encounter this kind of things when you write programs. Right? It's always that kind of feeling that you have. Right? You want to shout at the computer, why are you so stupid? My answer is correct. Right? It must be something wrong with your answer. You start to curse the programmer if the programmer is not you. Right? So how do we do that? So we go to the debugger to try to do that. I think you know the answer. Do you know? What is the answer? What is the problem with this? Let's go through it. Huh? So I turn on the debugger. Okay, and so after a few steps, I want to try to find the answer. So this is the debugger from the IDLE. From IDLE. So I'm trying to run the program, and at this moment it says that it has already have the first number. This one says that I got the first random number. The random number is 7. Okay. Then I run through it. Okay, then I get two numbers. The system randomly generates two numbers, 7 and 1. Right? And now it goes to this line. This line basically says I print out the statements, right? What is 7 plus 1? It printed out. Okay, and then wait for the input from the user. Right? So this line is line number 8. You say answer is equals to input. So you get the input from the user. And so you go step by step. You're using a step function or this step operation. Right? You go through step by step of your execution. And the result is shown on these places. Right? And then next one you say user enter 8. Right? 7 plus 1 is 8. So you look at the answer. So now they accept user's answer and you write it here. Right? And actually, at this point, you know what is wrong already. Right? What's wrong? What's wrong with that? String, right? The answer is in string format. It is not a number. It is a string, right? Because there's a quotation mark there. And therefore, no wonder they cannot be equal. A string and a number cannot be equal. Right? So that's the problem. So now you found the problem. You know how to solve this problem. Okay? So that's how you do debugging for small program. If you can, try to isolate a particular function, and then try to look into that and try to solve the problem. Okay, another one I want to show you, you use it very little here in this example, is called Python tutor. Okay, so I'm here already, Python tutor. This is Python tutor. Let me see. Okay, this is Python tutor here. You just type in Python tutor. Okay, this one is, and then here is the Python tutor. So they give you this piece of code, this space here for you to write your code inside, and then you can try to visualize the code. Okay, and this visualization actually is very good, in the sense that it's actually a tutor. It lets you understand how program is executed. It may not be very good for you to do debugging. Right? Unless you have some very complicated way of writing programs, then it's very good to show you that how is memory being used to solve the problem. Okay? So you're going to use that later on. So this is your program, you put it in, and then they will try to execute this program line by line, and then show you what happened when you're executing it. How is your program, how your program changed the memory so that it solves your problem for you. It's a very useful tool, so I encourage you all to use it. Right, so this is the case here. So I have a programs here. This is my program here, right? And I have 3 definitions here. And then I have this call here. Everything in one piece of code, right? And that's what it built up for you, right? It looks quite interesting here. So here is global frame. Global frame means something that is, when you load the program in, that's square in the shell, right? Everything is global there. And what is global? The definition of P1, P2, P3, they are global. Okay? And you can see that they have a frame that says that P1 refers to a function P1 here. And P2 here, it points to a memory location in which it contains the code for function P2, something like that. You'll see that in more detail later on. Okay? So we'll go to that later on. So let's look at debugging. Debugging basically, these are standard things. Humans make mistakes, so don't get too upset about making mistakes here, okay? But of course, try not to make as many mistakes in exam as possible. And you're bound to make some mistake when you're writing codes, okay? And the debugging, the purpose of debugging is try to remove errors or bugs from the program. And after you debug, the program is not necessarily error-free, okay? So, but this is a negative way to say whatever errors now remains are harder to find. Okay? But it's usually the case that you put in a lot of test cases and try to find out all the possibility, all the corner cases, then you should be able to get a program that is pretty good, pretty bug-free. There are some common types of errors. Right? For example, this one, these are standard errors. Right? These happen quite often. because we think of factorial, for example, this factorial definition, we think of it as a function, not as a program. And therefore, we forgot to write the word return here. Right? We always think of it as a function. Oh, you return this thing, but you forgot to write the word return. And this actually, system doesn't tell you that it's an error. Right? And so only when you run it, then you find that there's an error. Okay? This one is standard one, incompatible types. You define a square of x. It takes one argument. Here you do x plus square. What is square? Square is a function. X is an integer. They cannot add together. Simple. Right? And then this one, square 3, 5. One argument. It's expecting one argument, but you provide two arguments. These are standard errors, simple error. Right? This one, what it means is that you have a syntax error because the indentation has a problem. You indent it here and then you indent it here. It doesn't make sense. Everything should be indented properly. Right? Indentation is very particular is a particular problem for Python. Okay? Arithmetic error, divide by 0, that's very common. Undeclared variables, this one is quite easy to detect it, unless you write your code such that you have a piece of code, right? And then you write your function here, and then your function use k here, but k was defined outside in the global environment. That is usually the cause of the problem. That's why they say try to avoid using global variables. Okay, it causes a lot of it make it very hard to debug. Okay, this one infinite loop. Why is this an infinite loop? From that input, sorry. So you put in factorial 2.1, and every time you reduce by 1, so it's 2.1, 1.1, then 0.1. It never hits the point 0.1, then minus 0.1, right? So it doesn't hit the point where n is equal to 0. So you miss out the base case. It's not able to reach the base case, and that normally you'll go into infinite loop, never stop, or you tell you that what is it? The stack overflow problem. -1. This factorial is supposed to be taking positive numbers, but you put in a negative number. Of course, it goes into infinite loop because again, it's getting further and further away from the base condition. This is the base, the terminating condition. It's getting further and further away. You can never reach it. Okay? And normally this is the usual problem that we encounter, right? When you write programs. So this one says that I have a while loop. I'm testing of counter. If a counter is not equal to 0, I repeat the loop, right? And you see inside the loop, your counter never change. If your counter never change, counter start at 1, you initialize counter to n. Then the counter will remain at n. It will never become 0, and therefore it goes into infinite loop. This is a very standard or very typical problems in a program. Okay, this one, this is a bit tricky. Okay, this one says that I have a counter here. I increase counter by 0.1. Right, and counter start from 0. Counter start from 0, and it's supposed to reach n. So n is positive number. Let's say n is 2. So it increased by 0.1. So the first one is 0, then 0.1, 0.2, 0.3, 0.4. It can go up to 1.8, 1.9, 2.0, and then it stops. Right, because it hits this case. Right, 2.0 is not equals to 2. It should be equal to n. So this becomes false, and it gets out. But this doesn't appear. Why? Because you are playing with a floating point number, or we call it a real number. Right? There's a problem with this computer. Any computer is the same. It cannot represent floating point or represent real number precisely, accurately. Right? I don't know whether you learned that before or not. If you look at integers between 0 and 100, how many of them? 0 and 100. 101 integers inside, right? Including 0 and 100, there are 101 integers inside. They are finite number, right? If you take the real number between 0 and 100, how many of them are there? How many real numbers are there? Infinite, right? If I reduce it smaller, I take 0 to 1. Between 0 and 1, how many real numbers are there? Infinity. Right? You cannot count how many are there. Right? Real number is what we call, what do you call that? Finitely, it's uncountable. Okay? Infinitely countable. So it's infinity. Right? And because of that, computer as a machine, it has limited memory. It cannot capture all the possible cases. It cannot capture all infinite number of real numbers. Okay, so they do some approximation. Two numbers are approximately the same. Right? There are some different representations. Yeah, I think you have experienced that already when you write numbers in some of the tutorial question. Right? The answer is supposed to be 0.5, but you get 0.499999. And so this 0.49999 is not equal to 0.5. So it cannot do these kind of things. Right? You cannot do this thing. This one says counter is equal to n. And the counter is a real number. It's very hard for you to get the two to be equal. When you can get the two to be equal, you must be very lucky. Okay, so this problem is a problem with computers. Okay, it's called a numerical imprecision when you are dealing with real number. So this doesn't work. Okay, so normally what we do is that we do this. Counter is equals. You say counter is not equal, is less than n. Right? You can count that way. And then when it's above n, you stop. That's one way to do it. Okay? What about this one? This is a logical error. This one, the program will run pretty good, but it gives the wrong answer. Because Fibonacci takes two arguments, to make two calls here. One is n plus 1, n minus 1, the other one is n minus 2. But it's a logical error. This one, again, when your program becomes complicated, this kind of error can happen quite easily. So how do you debug? Think like a detective. Look at the error messages. Be calm with them. Okay? And eliminate all the impossibility. This is called a rule of elimination. Right? All those impossible ones, you throw them away. And run it again with different inputs. And try it out to see what happens. Okay? And then normally you have to work backward. There's an error there. I want to see what is the cause of errors. I have to actually work backward. I have to get the answer. And use a debugger. That is always good. And either is overkill for our class because our programs are so small, basically. Trace a function. That is normally what people will do. Means that when I call the function, when I get out from the function, I trace them. Right? When do I go in the function? When can I come out from the function? This is very useful when you write a lot of functions, especially for recursive functions, because you keep making calls and you can trace them. Display of variables. Okay, I'm going to skip this part. Okay. Other tips. You state the assumption clearly here. Right? This is a comment. It's a command. You just say that when I'm running factorial, n should be an integer, and it should be greater or equal to 0. Right? This is actually nothing. System doesn't know that. But at least as a human, when you look at it, you know what is it. Okay? So when I make a call to factorial, I know what it is going to be when I make a call to factorial. Okay? And we normally call this a contract. It's a contract between the caller and the callee. The caller will say that, I want to make a call to this function. And callee say that, oh, you can call me. Callee will say, you can call me, provided your arguments satisfy this condition. Right? We call this a contract between the caller and callee. It makes program building very easy. Okay? Test each function before you proceed to the next. Okay, I want to. So that's about debugging. Let me make a call again. Is Mr. Liu Chen Hui here? Liu Chen Hui? Okay, thank you. Debugging is an art. Okay, that is actually what happens most of the time, right? It doesn't work. Why? Then you hack, and say, how it works? Why? Right? I think you have this experience before, right? You have this feeling before. That's the case. Huh? I will skip this one. This actually is an interesting one. You can, I think you should be able to watch this, right? I'll skip this one. So there's a bug in the program when they launch this space shuttle up to the sky, and the bug is that a variable was declared wrongly. The variable is supposed to have an underscore or something like that, but I forgot to put in the underscore. You know the variable name? I suck. You put I underscore suck. That's a variable name. And the programmer forgot to put in the underscore inside. And he couldn't find it. During the testing, he couldn't find this error. So we went up, this one, the whole thing exploded because of a simple error there. Right? So you write program, that's why we say that we always ask you that when you submit your program, right, you go through this private test. We have this set of private test cases. You always complain, I work on the private case, it all works very well. I go to the private case, why is it wrong? Your private case must be wrong. Right? It's important that you make sure everything is correct. Computer is very precise. Okay? Even if a space is missing, who knows what will happen if the space is missing when you're writing big programs. Okay? Okay, now let's go to the other one. Okay, I'm going to talk about these things. It's quite important things. It's called data collections. We have dealt with numbers. We have dealt with the most complicated thing we have dealt with so far is called a string. Right? Even the string, you find that is very easy. Just a string. What's a big deal? Okay? But data collection is a very important concept in computer science or in programming. Okay? I put it, I have a power. Do you know this guy? Do you know this guy? Anybody know this guy? Sorry, this not your time. I watched this one when I was 15 years old. This guy is called the He-Man. Is it Master of the Universe? And he always take the sword and say, I have a power. Then he can solve all the problems. Okay, so data collection is, we are talking about a specific kind of data collection. Is called sequence. Basically, what it means is data structure. A data without structure is very hard to work on. Right? You can only work on integer. You can work on very simple things. You make a program not exciting, very simple. Okay? But with the collection, you can do many wonders. And you already have a power with you. Okay? So when we talk about structures or data collection, right, we look at some examples. So there's two worlds here. One is a primitive world, one is a structured world. Right? In chemistry, a primitive world you've learned already is atoms. Right? Hydrogen, oxygen, all these are atoms. They are primitive because that's the level that you need to go to. You don't have to go even further detail. I don't care what is inside, it doesn't matter. But I just want to know the atom because I want to know how atoms put together to form compounds. That's all I need to do. Right? I do not have to go into detail unless you are major in chemistry. Okay? So structure-wise, you also have the same thing. A molecule is a structure, right? It is composed from primitives, right? Methane is also a kind of things. And this one is called polymer. Polymer is a construction out of a lot of simple components, and that component is called a monomer. Okay? And you can see that actually it's a series. It's a sequence of things put together. Even with each element here, it's a sequence of things here. And each element itself is also a structure. So it's a complicated thing. And that's where the interesting comes from, because you have these structures. Okay? In programming, in Python, it's the same thing. What are primitive? We learned already. Integers, booleans, floating points. Right? All these are primitives. Primitive in the sense that we look at them as one. We don't try to break it down further. Unless you work on something like sum of the digit in the number. Then you purposely want to break it down. Otherwise, these are the simplest things. They are all easily represented in the memory of the computer. Okay? Structures. This is a structure, a rational number. In mathematics or in computer science, I think even in engineering, a rational number is not a real number. Right? A rational number comprises two numbers, two integers. You put them together, and that's a rational number. So you represent a rational number by two integers. Right? A student record in the course, CS1010E. Right? I want to know what is the student's record. It contains the student name, which is a string, student number, maybe a number is a string, or it's a number, and the grades of the student, maybe that's alphabet or something like that. So that's a structure. Right? This structure is just, it's a way to model a student in a course. Right? I'm not interested in whether the student is male or female, how old is he? I'm not interested. I'm only interested in the grade. What's his name? What is number? What is grade? Right? And that is sufficient. So again, we do abstract out, we look at the object, we abstract out what is important to us, we form a structure. Right? Sequence. Right? I want to capture all the marks in the class, and that is a sequence. Sequence means what? It's a series of numbers, or series of something. And that's what we want to concentrate on this week. Right? It's on sequence. Okay? String is a sequence. Set, also think of it as a sequence. Right? String is a string of characters, and that's all. It's a very simple sequence. Set means the set, you know what is a set, right? A set of numbers, set of items. We are not going to cover this today. Okay? So we call them a compound data, or call it data structure. Right? So you can store the mark of a single student by, how do you do that? By giving a variable name to this student. Right? I want to store the mark of the score of Peter. As I say, Peter's score. I do this. If I want to store the mark for a class of 50 students, what am I going to do? I'm not going to write this. I need 50 variables to represent 50 scores. That would be a very bad thing to do. Why? Because I want to operate on all of them. You imagine I want to find the mean, find the average score among the whole class. What am I going to do? I'm going to write a very, very long expression, right? Student 1 plus student 2 plus up to plus student 50 and then divide by 50. That is going to be crazy. Right? So we want to have a way to do that simply. Right? This is another example, Hungry Go Where. I want to find out, I store the data in the map, I want to find out, suppose I have 100 nice restaurants in Singapore, right? And my question is that I want to list out 10 most nearest restaurants that is nearest to me, to you, okay? So among the 100, I want to find 10 of them. So firstly, I need to record all this information, 100 restaurants, right? Record them in my program so that I can find the 10 nearest restaurants, right? So the question is, how am I going to capture these 100 restaurants? The first question I want to ask is, what information do I want to capture out of the restaurant, right? Since I'm looking at location, so maybe easier is just to capture what? The coordinates, right? In the map, what is the coordinates? So the x coordinate, y coordinate, you have a point there. That location represents the restaurant. This sounds an easy way to do and a valid way to do it. Okay? Right. And how do you store all this collection, all this data? How do you put them together? You have 100 of them. How do you put them together? And that's where we want to look into. It's called sequence. Okay? So sequence is a collection of something. Right? And you can be a collection of motions. Right? You know that when you take a picture or video for a motion, like this particular motion, right? What the video does is that they make it into frames, right? Many frames. And all these frames make together becomes the video. Right? I want to collect all these frames together in one straight lines or in one series so that I can go to them. I can even edit them. Right? So that is what we call a sequence. Okay? There are different kinds of sequences in Python. These are the most popular one. Strings, you know what is strings already? List is what we want to look at. It's a very important concept. There's a particular language that was used in CS 1010 as last time. It's called Scheme. Right? It's a very popular language because it was started from MIT. They taught it for maybe 20, 30 years for these things, called Scheme. This Scheme is a language that only has one data structure. The data structure is called list, or called tuple or whatever. Right? It's called a list. And with list, you can do almost everything you like. So list is a very powerful thing, and we want to learn that. Tuple, we will see what is the difference between the two. And then we have set and dictionary. Most likely we are not going to, no, it's not most likely. We are not going to cover these two today. Okay, so recap what is a string. Remember, we are talking about sequence. So string is a sequence of characters, right? So I'm doing this thing, my name here, right, is a string. How do I know it's a string? Because of the quotation mark, right? Single quotation mark. And then course code is also a string. And with this string, I can do something. I can find what is the course code, right? Course code is a variable. I can also index into the character in the string, right? So I say course code 2, index 2, it will be the 0, 1, 2. So it will be this one, right? so it'll be 1. So that's the case. So this is called indexing, right? So sequence allow you to do indexing. That's the first thing you know, right? You can also ask this kind of question. Print C in S, right? When you write in this way, you say whether the character C is in the string S or not. This one will return you a Boolean value. Boolean means it's true or false. Is C inside S? You learned this already? Okay? And this indexing, you know that already. So we are just a recap here. Okay? And string slicing, right? That's the thing in the first tutorial. We covered these things. You have a start, you have a stop, you have a step. Right? If you don't remember this, go back and read again. Right? And you know that this one, -1, what does it mean? The step is a negative. It means step backward. If it's negative, it means step backward. And by default, it means that you start from the end of the string and start stepping backward. That's always the case. Okay? And you know that in string, right? If I have a string here, right? Every character here, every character in the string has 2 indexes. Do you remember that? Every character in the string has 2 indexes. One is a positive one, the other one is negative one. So in this case, E is what? 0, 1, 2, 3, 4. Is index 4, right? Because indexing always starts from 0. So E is index 4. So you say S of 4, you get E. The other one is what? Index -2. Because you go from back, F is -1, E is -2. So every character in the string has 2 indexes. You have to remember this. Okay? Depends on whether you want to go forward, go backward. Okay? These are the functions that comes together when you use string as a sequence. If you use string, because string is a sequence, so you have all these functions available for you. Right? So this is to indexing. This is called slicing. Right? You slice a part of the string. And this is find out the length of the string. Find out the minimum of A. If you are giving me a string, what's the minimum? You look at the ASCII value and find the minimum of it. Right? And maximum, you can find the maximum within all the characters in the string. What is the maximum characters? Right? You can do this thing, test. Right? X in A. Okay? You can also do X not in A. You can also do that. They are just positive and negative. And then you can do this thing. Because it's a sequence, you can join 2 sequences together. We call it concatenation. Right? You take 2 strings and you put them together. Use plus. You can even have multiplication. And in the multiplication, the second argument, A, must be an integer. Right? Must return an integer. So that you can do a multiple times. Right? Create a multiple copy of it and then piece them together into one string. So these are standard things. I write it here because these are standard things when you talk about sequence. Okay? So sequence of string is like that. Sequence of list is like that. Sequence of tuple is also like that. There's no difference. Okay? Because they are all sequence. Okay? I want to skip these things. Okay? And go to list. So what is list? Strings is a sequence, a string is a sequence of characters. And list is a sequence of anything. Important thing is the difference between these two is that a list is a sequence that can contain anything. That makes list very powerful. Okay? Anything basically means everything. Every possible thing. So you can have these things. Okay? We call this variable is called even numbers up to 10. Right? Right? Or you can have this, my good friend, this variable is called, it contains a list of string inside. Okay, by the way, is it written here? Okay, so a list is represented by a square bracket. A string is represented by a quotation. Okay, a list is represented by square brackets, and to distinguish all the elements in the list, use comma to separate them. Use comma. So you need a comma. You need a square bracket to form a list. Okay. So this one is a string of, a list of strings. Okay. And what is this one? Answer to universe. It is a list of things. Whatever things can contain in universe. Right? So the first two is can be more than one type, right? I can say that I take out answer to universe, I take out a slice of it, 3 to 5. So what is 3 to 5? This is 0, 1, 2, 3. 3 to 5 means 3 to 5, not inclusive 5. So it's 3 and 4. So you get true and none. Why you return this? Make sense? You want to find how long is this list. You count them. How many elements are there in the list? So there are 5 elements, so it returns 5. It makes sense? All these are pretty intuitive. Right? You think of it as a list. So you can have a length of the list. Okay, so we have this answer already. Then you can see that this list, answer to universe, it contains multiple kinds of data. Right? So if you ask what is the type of this answer to universe, they say it's a list. This is a list. You say what is the type of the first element in this list? Right? First element 0. You look at it and say this is a string, right? It is a string. And what is the type of the second? The index 2. Index 2 is this one. Right? It says integer. And what about the last one? Index 4 here. It says none type. Right? This none is a special keyword in Python that says nothing. Right? This none is different from this nothing. The two are not the same. Right? This is the system. Python understands this means nothing. Python understands this means string. This string is not nothing. Okay? This string is not empty either. It is a string of nothing, contains the word nothing. Okay? So index, so you have all these things. You can have all these things. They are the same. Okay? So this concatenation means that you are joining two strings together. So I can do this thing. Even number 10 plus my good friends plus answer to universe. So basically the plus will join the string, the list together into a longer list. So now how many elements are there in this? We just sum up the elements, right? There are how many? 6 for the first one, right? 3 for the second one, and 5 for the last one. So it's 6 plus 3 plus 5, right? 14 of them. Okay? So how do I go? How do I extend this? What do I mean by list of anything, everything? It really means everything, right? So we can have this thing. I can have a list of lists. That's also possible. Okay? So this is where sometimes people get confused because it becomes the structure becomes complicated. Okay? So we want to cover this more carefully. So list 1 here is a list of integers. Make sense? This is a list of integers. List 2 here is a list of string. All this you can say is a list of characters, but here, because it's quotation mark, I say it's list of strings. Okay? Now list 3, what is list 3? It's a string containing how many elements inside? There's only one comma inside, right? So there are only 2 elements inside. What are the 2 elements? Lists. Right? List 1 and list 2. Okay? So when you print it out, it becomes this thing. Right? You look at the number of brackets here. So this is the bracket, this one, and this one is a bracket represent list 3. This is the first element. The first element is a list. And this is the second element. It is also a list. Okay? So this is very important to understand this thing. List 4 is a new list. It's true, list 3, list 1. So you represent in this way. Right? True here, first element. Second element is list 3. What is list 3? List 3 is this thing, right? So you get these things here. This is list 3. And the third element is list 1. This is list 1. This one is this one. Make sense? So it can get quite complicated. Okay? Structurally, you can look at it this way. We call it block diagram. I think it's called box diagram. I'm not very sure. Right? So list 1 is represented this way. That means conceptually, you can think of it this way. You can think of it that is organizing in this way, conceptually. Right? In fact, in computer, it's almost like this. So it's important to know that. So you can think of this list 1 is a list. This one tells you it's a list. It contains 3 arguments, 1, 2, 3. Three elements inside, not argument, 3 elements inside. List 2 is also a list. It contains 3 strings inside, A, B, C. Right? So now you have this diagram that is hierarchical. Right? Okay? List tree, what is list tree? List tree is like this. Okay? List tree contains list 1 and list 2. So list tree, I know that it is a list. List tree is a list. Okay? In this list, it contains two things. One is this one, list 1. The other one is list 2. Okay? Okay, and you look at this one here. This list has two names. This list has two names. One name is called list 1, right? One of the name is called list 1. So if I call list 1, I get this list, 1, 2, 3, right? The other name is called list 3, first element, right? If I make this call, if I use this term, I'll get to this list. There are two names coming to this list. Okay? This is this look pretty intuitive, right? It can become very complicated later on. We'll see that. Okay? So the sequence, when you have a sequence, that means there's a sequence of things there. You can create something called iterables. Okay? This is a little bit advanced concept. Iterable basically means that something that you can go through it and you can iterate your program by going through it. Right? So this is iterable for I in S. S is iterable because you can call for I in S. Then you go to the sequence, the character in the string one by one. So it's called iterable. Right? All these are iterable. The range is called iterables because this, by writing this, it allows you to go through 0, 1, 2, 3, 4, 5. It is iterable. Okay? And this one also same thing. You can write the same thing because they are both sequence. The range is a sequence. It's iterable actually. It's a iterable. And this is a sequence. Okay? And so if it's a sequence, you can also iterate throughout all the elements using the same format for something in something. Right? You can do this thing. Right? So this is a concept about iterable. Iterable basically means that if I have an object that's iterable, someone can say that, give me the first item. Now give me the first item. Someone can say that, give me the next item. So I go to the next one. So it's iterable. I can go through item by item throughout the whole things. Okay? So these are the same thing. So anything that can be looped over is called iterables. You can loop over a string, or you look over a list. Anything that appears on the right hand side of the for loop is iterable. So this is iterable. Okay? This is a list. List of even numbers. It is iterable. I'm just summing up all the even numbers in the list. Okay? So this is the format that we have for X in iterable. And I'm saying that a sequence is a kind of iterable. You can go through all the element sequence one by one from left to right, and do something about it. And therefore it's iterable. Okay? Now this question, just an example, I want to find the maximum in A, in a list of numbers. So given a list number, how do I find the maximum of it? Of course you can do this, right? You can do this, max, list, 1. Right? Because max is available, is a function available for a list, for a sequence. Okay? That will solve the problem. But I want to show you this code because of the algorithm. How I design the code to do that. Suppose I do not have a max, or I ask you to define a max yourself. That's how you find the maximum element. Okay? It's a standard, again, it's a standard pattern. When you write program, it's a standard pattern. That means it works on all the languages, programming languages. Okay? So I have to find, given the list, how do I find the maximum? Right? So firstly, I take out the first element. Take out the first element in the list, first item in the list. I say, this is maximum. It's called maximum so far. Max so far, I say, the first one is maximum. Okay? And now I go through the list. I go through the list. When I go through the list, that means I go through each item one by one. And every time when I pick up the item, that's called I. I check this item. Is this item bigger than this maximum so far? If it's bigger than this maximum, if it's not bigger, if this maximum so far is still maximum, then this item that I take, it cannot be a maximum, right? So I go to next one. If this item I pick up is bigger than this one, that maximum so far, what do? I change this maximum so far to this new item. So that's what it's doing here. If I is greater than maximum so far, then maximum so far becomes I. And then you loop again. Okay? So we call this, throughout this process, what is the most important most important properties here throughout this process? The most important property is that this maximum so far contains the maximum number so far that I process the list. It's always the case. Since the beginning, when I have only one element, the first element, this is the maximum so far. And then I go through the list, no matter which point I stop, right, this maximum so far, this variable, always contains the maximum so far I found. Okay? So when I come out from the list, surely I can return. When I come out from the list, from this iteration, surely I say I return maximum so far because I know maximum so far is the best. It's the maximum. So I can print it out. Make sense? Okay, this is a standard algorithm that people use. How do you find maximum? How do you find minimum? It's the same thing. Okay, but this one is a bit restricted in the sense that there are some assumptions that we make here. Is there any potential problem when you write this code? What are the problems, possible problems? What are the possible problems when you write this? I told you it's a standard code, right? What is a possible problem? When I say what is a possible problem, means that when I write this code, right, and I want to let the user, other people to use this code, I must tell them the contract, right? If you want to use my code, there's a contract you have to sign. This contract says that under what condition you should call me. If you violate this condition, most likely you get the wrong answer. That's a contract, okay? We call it a contract, we call it specification. Depends on, or we call it assumption. When you make this call, when you use this call, or use this function, what's the assumption? The list cannot be empty. Right? Can the list be empty? No. Why? Because I assume that there's at least one element in the list. At the very beginning, I already say that maximum so far is the first item in the list. Right? So that's not possible, right? If you give me an empty list, as this function, I'll just run it. And what happens is that I'll tell you there's error. Because you violate my assumption. My assumption is that this list cannot be empty. Okay? What else? This list must contain only integers or real numbers. It must be number that can be compared. It cannot contain a string inside. It doesn't make sense, right? Or it cannot contain other things, like a list inside. You can have list of lists. It cannot contain a list inside because you cannot compare. Okay? The assumption sounds, or the contract sounds obvious, but usually we forgot about that. And when people call your function, that programmer who call your function always also forget about this. He say, oh, maximum, let's call. Without knowing that actually the list can be empty. Okay? So that we have seen so far is list as a sequence. And we see that the function that we use are the same as a function for string. Right? For string. Like you have an indexing, you have a slicing, you can find maximum, you can find minimum, you can say something in something, right? In the list. Is this element in the list? You can ask this kind of question. List as a sequence comes with two other features. And that's what we want to cover here. Right? Two other key features is called append and remove. Append means that I want to add an element into this list. Okay? So I have this thing, my good friends, append, dot append here. Okay? This is not a function in the sense that you can call append and it will pass in the list. That's not the case. Okay? It's more like a method, right? I think you all do this, right? Some of you do this in one assignment 3 or something like that. You do this string, right? You have a string 1 and then you dot count, something like that, right? This is called a method. So this is a method also. And this method is called append. So it takes in one argument. Actually, it takes in two arguments. My good friend is an argument also for append. And then the John is a string, right? That's the argument. And what happened to this is that when you print it out, you find that this list is longer now. Just now, my group friends only contains 3 elements: Peter, Paul, Mary, and now John is inside. And append always means that you add it to the end of the list. The end and the front. The front of the list is the left-hand side. The end of the list is right-hand side. You always add it to the right-hand side. Okay, that's called append. Make sense? There's another one called remove. You can remove an element out of the list. Okay? So you have a list here. I say I want to remove. Again, this is a method. Okay? I put a dot here. This is a variable, a dot here, and then remove. This is a function. This is a function method. I want to remove 2 from the list. So I want to look up for elements which is equal to 2 and bring it out and remove it. Okay? So as a result, because I have two tools here, which one do I remove? And the answer is always remove the first one. That means the left-hand side, the one to the left. Okay? So this is a result of A list. After initially you have a 2 here, now there's no more 2 here. Okay, so these 2 functions, append and remove, is very useful here. Okay, only first appearance of 2 will be removed. You only remove 1 item inside. How about removing an item not in the list? Do I have an answer? How I do it? Suppose I want to remove A list dot remove 5. What will happen? Okay, unfortunately this system is quite nasty. You won't keep quiet and say, oh, you have removed 5, even though there's nothing changed. You say, no, you have removed, your removal is successful. No, they don't say that, they say error. Okay, you want to remove 5? No, you cannot. It's error. Okay, so normally you need to check, is there a 5 there inside? If there is, I remove. Okay, what if this one? What is this one? I have this thing. I have even numbers is 0, 2, 4, 6, 8, 10. My good friends is a list of 3 strings inside, Peter, Paul, Mary. I say my good friend dot append even number 10. What is the result? So I'm modifying my good friends. Because it's append, I want to add something to the end. Right? I want to add something to the end of the list called my good friends. So I add something to the end. Is this the right thing or is this the right thing? What's the difference between the 2? This one says that I have 4 elements. 1, 2, 3, 4. The last element is the list. This one says that I have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements in the list. These 2 lists are different. Right? If you ask for length of it, they'll give you a different answer. So which one is the right one? Which one is the right one? This is the right one. Okay? Append always add just 1 element in the list. Append add just 1 element in the list. Okay? How do you get this answer? If I have this thing, my good friends and even numbers, how do I get this answer? I will do this, my good friend plus even number 10. Right? Plus is concatenation. You take 2 lists, you join them together, it becomes a longer list. Okay? Okay, this is just a visual effect, a visualization of what is append. Right? Suppose that this is 1 item. Every model byte is one item. So this one is a list containing 2 items inside. Right? And this is also a list, but this list happens to be 1 item. This list contains multiple items inside. There are 5 people there. Right? And when you use append, what you get is a list containing 3 model bytes. You have only 3 model bytes there, 3 items. Right? But if you go into this item, the last item, you find that there are many people inside. That is called append. Right? If you do this, right, what it does is that you add them up. Okay, now you have 4 elements inside. So the plus and append are different. Append always append 1 element. Plus join two lists, and therefore the list becomes much longer. It's not just increased by 1. It's much longer. Okay? There are more differences. Okay? I want to show you these things here. This is, by the way, by the way, sometimes I use this machine because I want to run the code, right? And for some of you who look into the webcast, you find that this, whatever I showed here on the computer, you only appear there. It doesn't appear on this big screen. Okay? And when you go to the webcast, you find the webcast always show you this one has a big screen, and that one has a small screen. Okay? I don't know how to solve the problem, but I know it's a way out. I want to tell you the way out. There's something called Luminous. Do you know what is Luminous? You use Luminous, right? No? No courses use Luminous? It's the most advanced system in NUS. Okay? And if you go to our class, Luminous, if you go to our class called CS1010E, you scroll down, you go to web lecture, okay? The lectures are here. Okay? So what we do is that we take the lecture here, we put it into cosmology, and then you watch it in the cosmology. In cosmology, when you watch it, you use YouTube, right? In here, there's no YouTube. So I show you something here. I hope I can show you something here. What does it do? It returns 3
Okay.
students. This one, you see that the two screens are different, right? And now this screen is obtained from here. Right? This is, so on the right
Oh,
hand
that's
side,
my sound.
This part is,
Okay, this part is obtained from here. The system will automatically capture this thing and put it out. This one is obtained from the screen. And the screen one is always smaller. Okay? And what you can do in Luminous is you can do this thing. Okay? You can swap around and then you see the bigger one. Okay? Sorry, I do not have an answer for cosmology. When I use this, no matter what I do, I'm not using this. So just now I tried to run Python here. They don't install Python for me. So when I run Python, I need to use this. So if you think that you need to look into that, come to cosmology. Go to cosmology, find out what time is it. Come to Luminous. Look at the code here. Okay? Sorry, there's the inconvenience you have to go through. Okay, let's come to this. I want to show you this thing. What is the difference between plus, which is concatenation, and append, which is to join things together, which is to add one element into the list. So what is this thing? This is Python tutor. Okay? Python tutor. This is the one here. Okay? So what I need to do is that I take this code, I put it inside Python tutor. Okay, let me do it here. I have a code here. Let me see my code. Where is my code? My code here. This is the one, right? This is my code here. I copy this code. I put it inside here. Okay, and then I want to visualize the execution. Okay, so this is the screen that you see here. This is the one. Okay, this one it runs halfway. This one hasn't started running. So you say forward. Right, so let's see what it does. Okay, forward, you say I create a list. I run through number 1, line 1, I create a list. So list 1 have a list here. Okay, there's what we call this a pointer. This is a very important concept. You'll start to appreciate that later on. Okay, but remember this. List 1 says that this is my global friend. Global friend means my mother. Okay, the whole thing. The shell, okay? It says that I create a list here, contains 1, 2, 3, and then here, the name here, this list 1 here, is a variable name. It contains a pointer that points to this list. That's what it means, okay? So now I've finished executing list 1. I want to execute list 2. So what happened? It said this is list 2. I create this list. Okay, next line. I say list 3 is list 1 plus list 2. Okay, list 1 plus list 2. What happened? Take a look. List 1 plus list 2. So it's a list 3 is this. Is list 1 plus list 2. So you see the result. 1 plus 1, 2, 3, A, B, C, right? You concatenate the two together, and that result is called list 3. Does it make sense? Simple, right? It's concatenation. Okay? What is more interesting is that in this memory here, I have two lists containing 1, 2, 3. This is the one, 1, 2, 3. This is the one, 1, 2, 3. There are two lists inside containing 1, 2, 3. There are also two lists containing A, B, C. This one list, this one list. Okay? So actually there's a duplicate of information inside because I use a plus. When you see a plus, the system create a new copy. For the two arguments, they create new copy and then add them up. And then you get this result. Okay? This is the important point here. Let's look at it. What happens if I do list 1, append list 2? So I take list 2, I add it to the right-hand side of list 1, right? Add it to the right-hand side of list 1. So I will expect that list 1, because append always adding one element only. So I expect list 1 to have 4 elements. Correct or not? List 1 will have 1, 2, 3, and then the list 1, A, B, C. Yes, 4 elements. So what happened here? When I run it, that's what happened. List 1 contains 4 elements, 1, 2, 3, and then the list here is a pointer pointing to this list. Okay? List 2 still pointing to A, B, C, right? Never change. So you see the difference between append and plus? What is the difference? When you use plus, they create two copies. Each of the argument, they create a copy, then they add up. Right? So you have totally new content. When you use append, they modify list 1. They modify list 1 to have one more element inside. And this element is not, they do not duplicate this list 2. Right? They just point to list 2. So this becomes quite complicated. In fact, when you write programs, a lot of errors come from here. Okay, anyway. But it's good to know that. So next one, list 2, append D. What does it mean? I want to modify list 2 so that now it has 4 elements. The last element is D. So what do I do here? You look at it. I have this answer. Okay? I go to list 2, which is this list. I add one element inside, which is D. Make sense? Okay? What's important is that, what is this list 2 here? Right? List 3 is list 1 plus list 2. You look at it. What is list 3? Is it still 1, 2, 3, A, B, C? It has no impact. All these changes here so far do not change this list. That shows that this list 3 is a new list. Although the content is taken from list 1 and list 2, but it does not. After taking out the content, it is separated from list 1 and list 2. Okay? That's an important concept to see. Okay, last one. What happens if I remove 2? Right? List 1 here. What is list 1? This is list 1. It's 1, 2, 3, A, B, C, D, right? This is a list. So I want to remove 2. What happens if I remove 2? This remove, does it change list 1? Yes, it changed list 1. It removed 2 away. Okay? This is the important concept for list. Okay? Okay, so I've covered these things already. List 1, append. Right? When you do this, update the list 1. It does not create a new copy for list 1. It updates list 1 with one more element at the end. Right? This update does not change, affects list 3. List 3 is still like this, never change. Okay? And this one, same thing, you update list 2. And list 2 is here. When you update list 2, you know that it has impact on list 1. Because list 1 actually now, the last element of list 1 is a list that has one more element inside of it. Okay? But the list 3 still never change. Okay? So plus, if you use plus, it always returns a new list. It does not change the argument of the list. You take out the 2 arguments, make a copy, add them together, produce a new list. That's plus. Okay? String is the same thing. Whatever thing you think of, if the sequence, when you use plus, it's always do that. You always do that. Okay? Create a new copy, add up. That's actually something similar to call by value. You create a copy, right? Create a copy, pass it to plus, add them up, and return a new one. Okay? Now, also the other thing you have to remember, plus is a function, add up two strings. It returns a new list. It does returns you a new list. So when you say plus, you work on plus, you expect it to return something to you, return you a new list. So when you do this, it returns you the new list. Okay? It gives you a new list. That's why we call it a function. This one, append, is a method. It updates the current list. Right? It does not return anything. What do I mean by that? If you call list 1, append here, right? Append list 2. You find that there's no answer here. They do not return a new answer for you. Okay? So this operation, list 1 dot append list 2, you don't do this. You say new list is equals to list 1 dot append list 2. You don't do this. Why? Because this append update list 2. It does not return anything for you. It only updates list 1. It updates list 1. It does not return anything to you. So when you write this new list, what is this? None. It is none. Okay? But this one is different. Right? When you say list 3 is equal to list 1 plus list 2, it returns you an answer. It returns you a new list and pass it to list 3. Okay? That is always the error that people make when they use list. They forgot which one actually returns something, which one does not return something. Okay? So append and remove, I showed you already, we remove something, right? And append and remove, update the list. It updates the list. It does not return anything for you. Okay? So we call this a side effect. This execution of this append or remove has an effect. This effect is not to return something to you. This effect is I change something in the system. I change the list. That's the effect. Okay? List, the plus is what we call it. A plus is a function that returns you something. It has no impact on the other variables. We say this is a pure function. You never have any impact on all the variables. You don't change any variables. You just put them together, return a new list to you. Okay? Okay, look at this one. Right? How do I find all the even elements, even numbers elements in the list? Right? I want to form a new list out of a longer list. Right? So what do? I take a list here. I have this output. First, I want to return a list. I want to return a list that contains only even number. Right? I find all of them and return. So I start with output equals to empty list. I start with empty list. Right? And then I want to accumulate more things. So for I in the list here, right, I check if I is even, then this element, I want this element because this is even number. Right? So what do? Append it to output. So initially output is empty, right? Then output contains one element, right? No, not one actually. Maybe I is 2, you return 2. Then next one you append again. Maybe this one is 2 and this one is 4. Right? You keep adding it. Okay? And then you return output. So you return a list. Make sense? Okay? Yeah. Okay, this is just a sideline. You know that if a string of numbers, I can always, if you have a number, I can always turn it into a string, right? So string of 1, 2, 3 becomes 1, 2, 3 as a string. And then if you give me a string of numbers, I can say integer, then I return you an integer, right? String and integer can actually convert if it's a string of integers. A number string, numeric string, you can always convert to an actual integer. So this one is this is a data structure. This is a data structure. This is a primitive, right? This is a structure because it's a sequence. This is a primitive because it's an integer. You can do this conversion, right? But you cannot do this for the list. If I have this thing, list of 1, 2, 3, what it does is take this string and change its structure so that instead of a string, it becomes a list. it becomes a list. Okay? And when you say that I take this list, I want to make it a string, well, that's the answer you get. It is not clever enough to say that, take out all the elements, form it into a string. No, you won't do that. You say, oh, this is a string you want, right? We call this serialize it. So it becomes a bracket, 1, comma, space, 2, comma, space, 3, close bracket. This is a string I return to you. Okay, so it's not comfortable in that sense. Okay, next one, list comprehension. We are getting more and more complicated because it is powerful. Okay, list comprehension, let's look at it. What is list comprehension? Maybe it's a new term that you use. It's actually you use it in mathematics very frequently. You'll see that later on. So suppose I want to create a list, 1, 2, 3 up to 100. What do? There are many ways to do it, right? How do I create from 1 up to 100? You can do this, right? That's normally what you do. You create a new list called a list. You start with empty, and then go through this iterable, which is a range from 1 up to 100 inclusive, right? And then every time you have a new I, you just append it to the list. So you create a list from 1 up to 100. Okay? Or you can do this. This is more complicated. It looks more complicated. Okay? What is this one saying? It says that I want to create a list here. This list, how do I know it's a list? Because I have an open bracket, I have a closed bracket. So I'm creating a list. What does this list contain? This list contains I. This list contains I. How do I get I? I get I from here. Right? It contains I for I in range 1 to 101. Okay? You can think of it this way. So this item that really get kept in the list, I. Okay? And this one is the iterable. You go through it, right? I get all the I value. Anytime you get an item, you assign it to I. And this I becomes this I. Okay? You can think of it this way. I think this one is more comprehensible to you. What is this? This is a set, right? What is this doing? You say, I want to list out, this set contains I. What is I? I is taken from half open intervals from 1 up to 101. Right? When you write this way, you understand, right? When I write this thing, I, right? I is 1, 2, 3. What do you mean? It means I'm creating a set. This set contains I. Why I is 1, 2, and 3. So it's a set of 3 elements. Right? This is doing the same thing here. It's just that it's for the list. Right? This thing is mathematically it's called set comprehension. That's why this one is called list comprehension. When I say comprehension, it means this thing. You can write in this format. You have a bar here, in which this one on the left-hand side of the bar, it says what you want to keep in this set. What are the elements in this set? On the right-hand side, it says under what condition can this element be in this set? This is called comprehension, left and right. Okay? Let's look at it more. You will see the nice way of writing it. How do I produce a list of first 10 squared number? It means 1 squared, 2 squared, 3 squared, 4 squared. How do I get the numbers? You can write in this way. Right? It says that I want to go from 1 to 10. Right? For each one of them, when I get the I can be 1, 2, 3, 4, 5. What do? I return I times I. It's exactly the same as this. So as a result, what I return is 1 squared, 2 squared, 3 squared, 4 squared. Make sense? Right? This is called list comprehension. How do I produce a list of odd numbers? These are not very good examples, but we will show you how you can use list comprehension. How do I produce a list of odd number less than 100? Right? Of course, you can do this string slicing, right? You do, like string slicing, that means you do slicing, right? So you do this range here, right? You want odd number, right? Start from 1. The step is 2. So it's 1, 3, 5, 7. Then you get the string. Okay? How do I get, so this is the start, the stop, and the step. You know this already, right? You can do this for a range. How do you get an even number? Of course, you can do the same thing. right? Starting from 2, then step 2, 2, 4, 6, 8, 10. Okay, but I want to do a different one. Do a different way of doing it. Okay, I do this thing. This looks complicated. Okay, so it says that I have a least comprehension. I want to get I. Okay, I want to get I. What is the condition for I? First, I is obtained from range from 1 to 101. It means that now what is I? If I do this thing, what is I? I is 1, 2, 3, 4, 5, 6, right? But only one even number. So all these 3, 1, 3, 5, 7, I want to throw them away. So it says that I is in here if I is from here and if I is not in C list. C list was just not the list here. This is the C list. It's all the odd numbers. Okay? And here it says that I that I obtained from here, right, is not an odd number. So the system will do this, right? This is exactly what it's saying here. I is taken from the range and I is not in the list of odd numbers. C list is all the odd numbers, right? I is not in the list of odd numbers. You can do this. Okay? So it becomes a bit complicated. I give you an even more complicated one. How do I generate all the prime numbers less than 50? First, you generate all the non-prime numbers less than 50. And then what you do is that you have generated all the non-prime numbers. And then you go through the list up to 50, and each one of them you check whether it's non-prime or not. If it's non-prime, throw it away. If it's not non-prime, it must be prime. Keep it. That's all I do. Okay? So the first thing I want to do is generate all the non-prime number. Okay? So that's a general idea, right? So I want up to 50, or the non-prime number up to 50, right? So I go through what I know that is non-prime. It is what? Let me see. I go from I is from 2 to 8. Okay, that means I is 2, 3, 4, 5, 6, 7, 8. That's all. Okay? The reason I choose up to 8 is because of this property about finding a prime within a number of n, right? Within 50. How do I find prime or the prime number within 50? It says that the prime number must appear what? Must be smaller than the square root of 50. That's the property of number theory. Okay? So I go up to 7, that's all. And for each I, what do? For each I go through the step. I go through this step. So suppose the first I is 2, right? I is 2, so I say 2 times 2, that's the second one. 2 times 2, So it starts with 2 and then, what is it? So you have, 2 times 2, up to 50, and then every time you step by 2, I is 2, right? So you have 2. When I is 2, you have 4, 6, 8, 10, because every time you step by 2. Make sense? Okay? When I is 3, then what this one says, I times 3 is 6, and then every time you step by 3. Right? So it's 6, 9, 12, 15. So that's what you get this one. Okay? So every time you go through, you just print out the list. Make sense? So that's why you have so many lists. This list is when I is equals to 2. Okay. This list is when I is equal to 2. This list is when I is equal to 3. And every time you step 3 by multiple of 3, right? You add 3, add 3, add 3. Next one is I. This one is what? 4. Right? This one is 5. This one is 6. This one is 7. Okay? That's what you do. So I have this list, but that's not the answer. Okay? I want to have all these lists. I know that these are all non-prime. All these are non-prime, smaller than 50. Right? But what I want is a list of non-prime. This one is a list of lists. There are many lists here. So what do I do? Put them together. I do it this way. Okay? So I want J. Okay? And firstly, I want to generate I. And use this, whatever I generate, I use it here. Right? And with this one, I generate J. So this comprehension basically says that every time I have a new J, I put it to the list. Every time I have a new J, I put it to the list because I only want J. Okay, so you have a list of all the non-primes in one list. Okay, this one you have to go back and think. How do you generate this? All right, so this is I equals to 2, I equals 3, 4, 5, 6, and go on. Okay, and the last thing is when I generate all the non-prime, the next thing I want to do is generate all the prime. Right? So this is how I generate all the primes. Right? That's what I do here. X, right? For x in this range, I go through all the elements from 1 to 50. Actually, it's not 1. 1 is not a prime, sorry. It should be from 2 to 50. Right? And every x that I choose, I check x is not in non-prime. Then I'll throw it away. If n is not in non-prime, I keep it. If x is in non-prime, I'll throw it away. Okay? So I've covered list. Next, I want to cover tuple. Okay? Tuple is basically a list. But tuple is a little bit different. It cannot be modified. Right? For example, this is a tuple. Tuple is represented by this, a bracket. A bracket is a tuple. Okay? And I can say that this bracket contains sequence, right? So it's bracket and comma. For a list, it's square brackets and comma. Okay? So a tuple, the I, index I means this one, this element. So index from 0 is the same thing. Okay? If you want to change something, I say the second element, index by 1. That element I want to change to 9. The system will say, no, that's not allowed. Because tuple, you cannot change anything in tuple. Tuple is something set. Something fixed, you cannot change. Well, list you can change it. That's the difference between tuple and list. Okay? I want to change the tuple so that I add in a new element into the tuple. You say, no, you are not allowed to. I say, I want to remove an element from the tuple. You say, no, you are not allowed to. Because it's not changeable. Okay? Make sense? So it's a simple kind of list, right? You cannot change, basically. It's a sequence. It's still a sequence. Okay? So when you have a list, you write in this way, right? This is a list. How do you write a list of one element? Why you write this, right? This one is a list of one element. Make sense? Okay, this is a list of one element. Nothing special here. If it's a tuple, this one create a tuple of 3 elements. We call it a triple, right? You can call it a triple. Right? It has 3 elements inside. What happens? How do you create a tuple of 1 element inside? A tuple of 1 element inside. Right? If you write in this way, this is a tuple of 1 element, right? And then you print out the tuple. It tells you 3. You say, what is the type of this tuple? It's integer. This is not a tuple. This is an integer. Okay? You cannot just write tuple 1 element by writing this. What is this thing? This is arithmetic. It says that do this first, right? Bracket means do this first. Right? So it's a 3. It's 3. So what do? You write this way. You write this way. You put a comma there to say this is a tuple. So now you say, oh, this is not an integer. So now when I ask what is the type here, it says a tuple. It's a tuple, and I can find the first element in the tuple. Okay, make sense? Okay, but then why you want to use tuple? Right? It's normally a cultural reason, right? You normally when you use a list normally, it contains is a large collection of data. Especially now you're talking about big data analysis or thing. Normally things are captured using a list. Okay? So a list is a back thing. A list can be considered as a vector, matrix, all these are lists. Okay? So a list is a large collection of data which are of the same type. We call it the homogeneous data, like a list of integers, a list of floating point. These are lists. Okay? Tuple is usually a small collection. That's a tradition. It's culture. We always do that. It contains, each items inside are different kind of types. It can be different things inside. That's what we normally do for tuple. Okay? When something is small, something you know that the size is fixed, normally you use tuple. When something you don't know how big is the size, you want to add in more things as possible, then that's a list. Okay? So for example, this case here, right? There are location of 100 nice restaurants inside. How do I represent this restaurant? I say that I represent it by x and y coordinates of the location, right? And the first question is, oh, I need two things, x and y location. Should I use a list? Should I use a tuple? Well, the answer is simple. Only two elements. Can it be more than two elements? If you are describing a location, x and y. Do you want another one, z or something? No, not possible. Right? Just two is good enough. So it's fixed size. It's small. Use a tuple. So that's why it's a tuple here. Okay? What about you want to contain all the 100 nice restaurants? You want to contain all the locations? 100 of them. Should I use a tuple? Should I use a list? Well, this 100 may change. Right? Initially, maybe there are 50. Maybe later on, there are 110 restaurants. So I want to be able to expand it. So more like it's a list. So I write in this way, right? Location of nice restaurant is this way. It's a list of tuple, right? And in the tuple, the first component is x-axis, the second component is y-axis. That is very fixed. I know what is the format for this data, okay? So I have answered this question already. It's a list of tuples of two elements, right? A list of multiple elements, a tuple of two elements, two components. Okay, so I can have this thing, I can write in this way, and I can find a restaurant. This one is simple now. I will not go through these slides. They're simple things. You want to generate. So how do you find the nearest restaurant? You find your location. What is your location? It's a tuple of two components, x and y. You look at a restaurant, you find the distance between this point and this point, right? How do you do that? This is assignment 3, question 5, right? Question 3, right? You find, what is it? Find the pi, right? Or you find the distance, right? You do that. You find two locations and then find what is the distance. If the distance is within the circle, you count it. If it's outside the circle, you don't count it. Remember? There's a finding using random number to generate pi. So this is the same thing. How to find two locations? The distance, x squared plus y squared, square root. Right? That's what you do. And so you want to find those locations that is near, is within the distance range. If it's the case, I keep it. I use a list to keep it. I use a pen to keep it. Okay? Wow. Okay, so this code is actually finding restaurants. Did I write it here? Yeah, this is code that finds restaurants, right? So firstly, I generate a list of restaurants, 100 of them, let's say, right? So I'm using this method to draw. This is a method that generates the list. This is a random method. It's not really the real location. The location is defined using, is calculated using random number. Okay? So I generate these things, and then this is a list of location, and then I use distance. So you have all the location here. For each location, you check my current location and this new location. What is the distance? If the distance is less than this, the range that I have, then it's considered as near to me. I keep it in the list. And later on, I output it. Okay, so there's nothing much there. And the challenge is now it returns, you can find all the nearest restaurant. Can you find the 3 nearest restaurants? Among them, what are the 3 nearest? It's not that difficult. That means the nearest means the distance is the shortest, right? You can try to do that. Okay, I want to skip this, not skip, I'll cover this next week. Just to complete this part about lists and tuples. So lists and tuples, what is the difference? Is immutable versus mutable. Mutable means you can change. Immutable means you cannot change. So a tuple is something that once you create, you cannot change it. A list is something that once you create, you can change it. So a tuple is like right protection, you cannot change it. So I don't know whether you remember these things or not. This is what we call a disk, right? Old time we have a disk. Like this is a hard disk, this is a floppy disk, and there's something here. It's a lock. When you push up the lock, you cannot write into this disk. When you open up the lock, you can write into this disk. So a tuple is like you push up the lock and say you lock this data. You cannot change it anymore. Okay? List can be changed within a function. Okay? And it's not passed by value. I want to show these things. This is a very important concept. So I want to show it next week on these things. Right? It's about passing by value. Remember, pass by value. When you call a function, you pass a value over. Remember that? But when you're passing a list, then that's totally different story, because a list is not passed by value. Okay, we are going to show this next week. Okay, so I'll stop here today. And once more, thank you for the mock exam. We really learned a lot from there. And those people who need to do a makeup, we'll inform you. I think we have already informed you already. When is the makeup time? It's going to be this Thursday. Okay, thank you.
Regarding the assignment 3 question 1, right? So what happens that you say there's no sort or sorted functions, right? So let's say if you use lower or upper, is it considered a function? Lower or upper? To change the
So long it's not sort.
it's not a sort. Thank you so much.
So after this, right, then the dictionary, then what else is the content?
Higher order function
Higher order function.
and object order programming.
Then
And then
that's
we
the,
look at the application. There is an image processor.
wow,